All right, welcome to the review session for the final exam for Math C112. Go ahead, you guys can ask questions. You guys know how this works. Yeah.
What do you need to know about the refractive index?
Yeah. So what does a refractive index describe in a material? Does anyone remember way back then? No, don't remember.
I think it had to do with the chart, right, where it reflected back the wavelengths and stuff.
Well, so refractive index. Wow, that is the worst piece of chalk. Refractive index refers to, what do you use to make a refractive index measurement? Does anyone know? I heard it. Light, right? So when you shine light on a material, what happens? Yeah, so it absorbs, what else? Reflects. What else can happen? Transmits. Scatters. So the intensity equals RATS. That's how we remember that. So the intensity is absorption, reflection, transmission, and scattering. And so you know, or you realize here that none of these are refracts because refraction is a type of transmission. But when you have, say, if you have a nitrogen molecule, so here's the nitrogen atoms, and here's the electrons right here. The electrons are buzzing around, and you send in light to this thing. What's going to happen to these electrons in this nitrogen molecule? Does light have any effect on electrons? What does it do?
Excites them?
It can excite them, yeah, so you can make an excited state. But say you don't excite them, what happens when this light wave interacts with an electron? Just shakes it around a little bit, right? So these electrons are whizzing around these nitrogen atoms here in this nitrogen molecule. But when you send in light, you basically can polarize this molecule. And so the polarization of the light, or the light coming in, will shake those electrons around. And now this matters for refractive index, because what if you have fluorine versus, let's say, nitrogen? Which of these molecules holds onto its electrons more tightly? Fluorine. Why do you say that? Because it's more electronegative, right? So you remember all that stuff about electronegativity. What's the most electronegative element? Fluorine. And electronegativity basically increases as you move towards fluorine. And so fluorine, it turns out, holds onto its electrons very tightly. And so you remember the discussion about polarizability. Sorry for the horrible board. I don't know what's wrong with it. You remember the discussion about polarizability, and so what molecule is more polarizable? Fluorine or nitrogen?
Nitrogen.
Nitrogen. That's the great answer. So you can look at the bonding and all that stuff, and that doesn't matter as much. It's electronegativity. So fluorine holds on to its electrons very tightly, so this is low polarizability. This is higher polarizability. Great. Now, which molecule has a higher refractive index? Or which material would have the higher refractive index? The one with low polarizability or one with high polarizability? It's 50-50. What do you think? What's that?
Nitrogen.
Nitrogen would have the higher refractive index. And so remember the college, so what's the high school definition of refractive index? Does anyone remember? The speed of light in a vacuum divided by the speed of light in a medium. So we don't use that definition anymore. Refractive index is the ability of the material to respond to an oscillating electric field. So when this light comes in, light is basically an oscillating electric field, right? It's a wave. And so this wave comes in, it shakes the electrons around in nitrogen, and for a material that responds a lot to that oscillating electric field, that's a high refractive index. For a material that doesn't respond very much, that's a low refractive index. And so this also is related, and that's related to the polarizability. And so I think in lecture, is it 4? I looked at them all yesterday so I could figure out where everything was. Three. Okay, so we have polarizability. So you have polarizability, and it's got all these factors in it. That's not as important as what we call the dielectric polarization. And so you can see the dielectric polarization here, or this could also be the refractive index, or the dielectric constant changes as a function of frequency, and you have these different molecular motions that you access. And so the one interesting thing about this is, let me see. You're looking for the review sheet? Yeah. I'll put it up in a second. So the polarizability, so you see that alpha here, these alpha values are the polarizability. However, that's related to the dielectric permittivity of the molecules. And so you have this idea of how polarizable is the molecules, or how polarizable is the material, and how does that relate to the dielectric permittivity or the refractive index or the dielectric constant. Let's see, what else is in here? Yeah, so dielectric permittivity is a measure of the ability of a material. Okay, that's fine. Yeah, refractive index and dielectric permittivity are related to the polarizability of the material and describes its ability to respond to an oscillating electromagnetic field. So the important thing to remember, the question was about refractive index, right? The important thing to remember is that the refractive index is related to the dielectric permittivity, and it's also related to the polarizability. And so if I ask you something about one molecule that has a low polarizability versus one molecule that has a higher polarizability, you should be able to tell me which one's got the higher dielectric constant, which one's got the higher dielectric permittivity, which one's got the higher refractive index. Yeah?
So are they directly related, all of them?
They're not proportional, but they're, the high refractive index.
High equals high.
High equals high, low equals low. Yeah. And like I said in the review, you don't need to know all these complicated equations. So if these equations are not on your review sheet, you're going to be fine, but you want to know this important part right here. Let's see. Yeah, dielectric permittivity is measurable, polarizability is not, refractive index, all of this stuff. So these are concepts that you'd really like to know. You good with refractive index? Okay. Yeah, polarizability is key there. Where else is polarizability important? Does anyone remember? Wasn't there a question on the first exam about polarizability? You guys remember that? Question number 6, perhaps? Was it? Yeah, exactly. So let's see. Let me see who's got that exam one. I don't remember. Oh, well, no, sorry, not 6. 9. At room temperature, the natural stable phase of the following halide elements is given below. Let me just while we're talking about polarizability. There we go. Okay, at room temperature, the natural stable phase of the following halide elements is given below. Explain these observations in terms of the van der Waals interaction energy. So why is fluorine a gas and why is iodine a solid? So which one's got the higher van der Waals interaction energy between these molecules? Large or small van der Waals forces between solids? Large. That must mean small. So why is that?